So in this video, I'm going to discuss the building an aquarium problem which often today's CODEFORCES challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I'll provide both the links in the comment section. I'll pin them. So the problem statement I won't discuss much because you know it. So it's basically you have to there's an aquarium which is where the bricks are of length. Okay, so let me draw this. Okay, so it is, so first let me write the array. It is 3 1 2 4 6 2 5. Okay, so that is over here there are 3 blocks, 1 2 3. Over here there is 1 block, over here then there is 2 block. Okay, then there are 4 blocks, okay, then there are 6 blocks, okay, and then there are 2 blocks, and then there are 5 blocks. Okay, so basically this is how it looks like. Okay, so this is how it looks like. So now we can do what we can apply walls of length h over here and here, so that there is also given x. Okay, so it has to be, we have to maximize the volume of water that it can hold, remembering that we have to use at most this liter of water. Okay, so for this what we have to do is, so the general formula is if you have already faced such a similar problem, over here what we do is you have to find the maximum height towards left and maximum height towards right. Okay, so maximum height to left and maximum height to right, and then you have to maximize them, so that is maximum of both. And if this result is greater than ARR, that is what, okay, ARR of I, that is the height of the respective pillar, then the amount of water that pillar holds on top of it is equal to this maximum. So let's name it M. So that is going to be M minus ARR of I. Okay, because very simple thing. So if something is let's say there is one of height this, one of height this, height this, height this. Okay, right. So if we consider just this block, so what is the water? Okay, so let's say over here also this. Okay, so what is basically the, so over here if we draw another one over here, so for this case you can see that the maximum height of water that it can hold is like this, right? So this is going to be this much, right? So that is maximum of both the sides, that is from left this is the maximum and from right this is the maximum. Actually I made a mistake, this is going to be minimum of both them. Okay, minimum of both of them. Okay, so once you are done with this, so you can get just for one respective what is the water it can hold. So using this formula what you can do is, let's say low is equal to 0 and high is equal to 10 to the power 9, and then use a binary search algorithm to find all the to estimate the height. Okay, so this low and high is actually the height, that is, okay, height of the pillars of the walls on either side. And once you have estimated it, so you can compute it and check, and that's how you're going to get the answer. So for this case, so 3 1 2 4 6 2 5, obviously we are not going to check from 0 to 10 to the power 9, so there we are going to do the calculations. But what we can do is we can find what is the maximum capacity of water if the height of the wall is 4. Okay, so if the height of the wall is 4, so we are going to consider a 4 over here and a 4 over here, right? So for this 3, so let's say the capacity is initially 0, so for this 3 it is going to be, over here the maximum is 4 and over here the maximum is 6, right? So what is the minimum of them? 4, so that is 1. For this maximum is 4, maximum is 6, the minimum is 4, so 4 minus 1 is 3, so that is 1 plus 3 is 4, right? Now for this case, over here it is 4, over here it is 6, So we are going to consider 4 again. 4 minus 2 is 2, so 4, 5, 6, right? So for this 4, 6 and 4, so 4 minus 4 is 0, so we don't change it. For this 6, over here it is 4, over here it is 4, and 6 is greater than both of them, so we don't consider it. For this there is 4 over here, there is 5 over here. I think I did a mistake. So for this 4, actually there was 5 over here, okay. So but anyways, doesn't matter. So over here there was a 4, so this 5 gets nullified, okay. So for this 2, the maximum over here is 4 and the maximum over here is 5. So 4 is something that we have to consider, because minimum of 4 and 5 is 4. So 4 minus 2 is 2, right? So it becomes 8. And for this 5, the maximum over here is 4. Sorry, the maximum over here is 6 and the maximum over here is 4. So this 4 we have to consider, because that is the minimum possible. So basically this is going to be nothing, because 4 is like 5 is greater than 4, right? So it remains 8. So that is the best possible solution, okay. We can't attain 9, but the best that we can attain is 8. So this is how we are calculating it, okay. So I hope this is very much clear. That is maximum to left, sorry. So the formula is basically the capacity, that is I'm telling you how to calculate the capacity portion, that is run a loop from 0 to n minus 1, and capacity plus is equal to maximum of left of I plus maximum of right of I, sorry, not plus, it is going to be minimum of these two values, okay. So that's it from my side. I hope this one was clear. This is simple binary search and like simple logic. So that's it. Thank you.